Hello and welcome to this tutorial. In this discussion, we shall be looking at the turning point and the axis of symmetry of a quadratic graph. Before we proceed, make sure you click on the subscribe button, like and share. Now the graph you see on the screen is a quadratic graph. Now, if you consider the values of the function from this side, tracing downwards, what you get to realize is you have decreasing values of y, which are the values of the function. So as you come down, or as you move down, you have decreasing values of the function. At a point, somewhere here, the graph pauses. Then what happens? It then proceeds with increasing values of the function. So as you begin from this point, what do you see? The values of the function start increasing, or the values of y start increasing. Okay? Take note of this point. It's very crucial. This point is known as the turning point. Similarly, if you have a similar graph like this one you see here, okay, this one is curved upwards. At this very point you see here, we also call that the turning point. Why? If you look at this side of the graph, then you move up, you get to realize that the values of y are increasing. Then when it gets here, it momentarily stops and then starts decreasing. At this side of the graph, you realize that the values of y are simply decreasing. So what then is a turning point? The turning point is a point where the function changes from decreasing to increasing, or from increasing to decreasing. Now let's consider the axis of symmetry. Consider the graph on your screen. Now, as indicated here is a turning point. Let's introduce a vertical line that is going to divide the graph into two symmetric parts. If this vertical line passes through the point where x is equal to d, then we can simply say that the equation of this vertical line is equal to x is equal to d. Now, the line that divides the quadratic graph into two symmetric parts, or into two equal halves, is known as the axis of symmetry, or the line of symmetry. Now, let's just indicate the x-intercepts of this graph as alpha and of course beta as well. And remember, these are also known as the root of the corresponding equation determined from that particular function. Let's also introduce the other graph as well, but this one curved upwards. Once again, we have our axis of symmetry here, and our equation also equal to x equal to d, because if the point it passes through is d on the x-axis, then we can simply say that the equation is equal to, or the equation of this axis of symmetry is equal to x is equal to d. Now, we can determine the axis of symmetry, or the equation of the axis of symmetry, by using the root. If the graph has x-intercepts, the equation of the axis of symmetry can be gotten as follows. X is equal to half, brackets open, alpha plus beta, brackets close. In other words, the equation of the axis of symmetry is simply equal to half the sum of the roots. where alpha and beta are the x-intercepts or the roots of the equation ax squared plus bx plus c equal to 0, which is the corresponding equation that can be gotten from the function by setting the y equal to 0. Now, in case there are no x-intercepts, look for two x values that have the same y value, corresponding y value. Add those two x values and divide it by 2, and that will give you the right hand side of the equation of the axis of symmetry. Now, through calculus, given y equal to ax squared plus bx plus c as the equation of a quadratic function or graph, the axis of symmetry is given by x is equal to negative b over 2a. How is this gotten? Here, we differentiate y with respect to x and then set our resulting expression equal to 0, since at the turning point, the gradient there is normally equal to 0. Simplifying will result to the equation x is equal to negative b over 2a, which is the equation of the axis of symmetry. Now let's look at this example. Below is a graph of the function y is equal to 3 plus 2x minus x squared. Use it to find a, the equation of the axis of symmetry, b, the turning point, c, the value of y when x is equal to 3.5. Solution. Let's start with a, the equation of the axis of symmetry. Now, as we discussed earlier, the axis of symmetry is an imaginary line that divides a graph into two symmetric parts. Or better still, it divides a graph into two equal parts. Now, look at the graph carefully. Can you imagine where the axis of symmetry might be located? If it is hard to do so, just consider where the graph intersects the x-axis. It intersects the x-axis at x equal to negative 1 and of course x equal to positive 3. If you add negative 1 to 3, we have 2. Dividing it by 2 will also give us 1. In other words, negative 1 plus 3 all divided by 2 will give us 1, and this is where it's located. So now if you trace a vertical line through 1, you get to realize that this vertical line is going to divide the graph into two equal parts. Now, as I also said earlier, times when there is no root or the graph does not intersect the x-axis, you can also pick two x values that have the same y value. On the graph, you get to realize that negative 2, as you can see here, has a corresponding y value of negative 5. And again, positive 4 also has a corresponding y value of negative 5. So, to find my axis of symmetry, I can simply add these two numbers, negative 2 plus 4. That will give me 2. And now dividing that result by 2, I still come back to the same answer, which is 1. So again, tracing a vertical line through 1 on the x-axis, what you have is your line of symmetry or your axis of symmetry. So we can trace a vertical line as seen on the screen. Okay, now since the vertical line passes through x equal to 1, then from the graph, the equation of the axis of symmetry is simply x is equal to 1. Let's come to the b, the turning point. Now, once you're able to identify your axis of symmetry, then you should know that the axis of symmetry passes through the turning point, which is obviously at this area you see here. Okay, so when you trace down from that point, we have it there pointing again to the 1 which we had earlier for the axis of symmetry. And then if you trace horizontally to the y-axis, you have the y coordinate being 4. So using our x equal to 1 and our y equal to 4, we can derive our turning point. So from the graph, the turning point is simply 1, 4, or better still, the point of coordinate x equal to 1 and of the y coordinate equal to 4. Let's come to see the value of y when x is equal to 3.5. First of all, you locate where 3.5 is on the x-axis. This is 3 and this is 4. That means the middle portion should be 3.5. Here is it. So we use a vertical line to trace towards the graph. Whatever the vertical line touches the graph, we then trace horizontally to the y-axis, and that will also give us a corresponding y value equal to -2. Okay, so we can say that from the graph, when x is equal to 3.5, y is equal to -2. Thank you for your time. Kindly try and subscribe. If you don't subscribe, this might be the last time you get to see this channel. If you want to have the chance of seeing our videos again, kindly subscribe and click on the notification bell so that you can always be the first to watch our video anytime we upload. Thank you for your time. God bless you.